Right. Hello and welcome to the June 10th live stream for Algebra 1. And this is the part where I wait for people to show up. But I can't post the questions. I don't like people taking a peek at. I kind of wanted to talk about, based on the emails I've got, there are some interesting looking square root graphs. And so I kind of wanted to talk about graphing square roots a little bit during this, and then just kind of generally talking about parent graphs before we jump into moving them all around, and then also talk about ways to submit the homework, because we have people submitting through a bunch of different ways, and I want people to be aware of all of the different ways that are cool for submission for these, because I accept a whole bunch of different ways. Anything you can do that looks, shows me you did some of the assignment or all of the assignment is pretty sweet. That is the goal for today. Doom doom. Huh. Oh, we got people trickling in. Hello, if you've shown up. There's some questions for you to try out here. You feel so inclined? Kind of gonna be focusing on graphing today. What I spent my intro ranting about. And I'll be going over these in like, I don't know, 13 minutes or so. Kind of see on how people do when they start showing up. Tomorrow is the graduation-ish thing. So senior staff is very busy right now. You? Losing people. Oh no. Hello, if you are here. I can say from looking at the homework that people seem to struggle a little bit more with the actual graphing of things than with previous stuff we had done, like the online homework sort of stuff. So definitely some things worth talking about. So I'll find a way to keep myself busy even if not too many people show up. Feel free to say hello or write any answers in chat if you want to do so. Hey Anders, welcome, welcome. I wonder, this might be our last live stream actually, because next week's gonna be pretty chillaxin'. We're kind of through most of the major content. Like all we have left is translating parent functions. That's it. There's nothing else left on the docket for this year. So we're going to be moving these things around and stretching them and shrinking them. And other than that, nothing. So the parent function dump was the last big thing of the year. So that's kind of exciting. So yeah, if you're here and you'd just like to see me do some questions, you feel free to write done in. If you're like, yo, I want to practice these before you try these, feel free to just let it sit for a minute and then put in a done when you think you're ready. I'm good with either. And I'm just here to help where I can. Hey, Jessica. Welcome, welcome. First period, by the way, which you two are both in, for our fifth period, is dominating so far in terms of homework completion. Even our boy Zongchi made a comeback here and actually finished a ton of his assignments. So we're getting like greater than 90% homework completion rates in fifth period, which is like way better than my other two periods, which are both around like 70, 80%. So, good job, fifth period. Seems good. So yeah, you don't have to write any answers if you don't want to. If you just do the problems, then just tell me when you're done, then I'll run through them. Be too bad. I will be patient and I promise. All right. 50% of the people here are done. So I guess I might as well take a peek at these. All right. So for the first one, it says write the equation of a square root graph that is shifted right 3 and down 6. So we know it's going to look something like this. The down 6 is easy, that's a minus 6 on the outside. And the right 3 is going to be a minus 3 on the inside, like this. And that's it. That is shifted right 3 and down 6. The next one, graph y equals x cubed and y equals 2 to the x on the same graph. Y equals x cubed looks like this. That's 0, 0. I goofed and missed. And y equals 2 to the x looks like not like that. Let's make it look better. Like this. And kind of a little interesting added anecdote is that in calculus, we learn about the slopes of these things, and this guy gets big way faster. So 2 to the x is way bigger when you plug in big values than x cubed is. Like, it's not even a competition. This goes up way steeper than the x cubed guy does. But, yeah. It's a little extra piece there. For the next one, graph the following. One thing I noticed looking at people's homeworks actually was that a lot of people were getting the starting point right, but then the graph looked a little wonky. So -2, 3, you put here, -2, 3, that's the starting point. The opposite of this, this. And then from -2, 3, we're going over 1, up 1. And then we're going over 4 from our starting location and up 2. And so it ends up looking like this, something that's getting less and less steep as it goes along. I saw a lot of interesting looking graphs like this sort of thing for square roots, and square roots won't ever look like that. Square roots always look like either this or this or this or this. Those are all the possible options. Every one is getting flatter as it goes out to whichever direction it's going. Hello, Rachel? That is not a person I know. Alright. Next one says state the domain and range for the square root in question 3. So the domain for this square root is, since it's... Oh no, I left it on eraser. Good thing there's an undo button. Hey, alright. Since this thing starts at -2 and then goes to the right forever, our domain is just x is greater than or equal to -2. Our range is we're starting at our lowest y value, which is 3, and we're just greater than or equal to that value. And that's it for domain and range. Domain and range for square roots are pretty easy. Although, to be honest, domain and range for square roots are harder than domain and range are for, like, lines. If you watched my video for parent graphs, you saw that a ton of the things had, like, domain and range of all real numbers. If the arrows go all the directions, you just get all real numbers. And so these are even easier than square roots are. Are we having a final? No. So, to my people watching, if somebody has a 70% in the class and an 85% on their quarantine homework grade, what letter grade will they receive in my class at the end of the semester? So this means you're not answering with a number, you're actually answering with a letter and then a plus or a minus, maybe. Let's see what you got. Did I answer the final question? I think I did. We are not having a final. No final. We could have a final, but we're not going to have a final. Haha. Anders, it isn't quite an A. Jessica got the right percentage, but what letter grade would that get? That's the true question. And the correct answer would be, yep, a C+. So, all I do is I go halfway in between these two, which was 77.5, or add them together and divide by 2. And then I just give that letter grade and grade adjust. That I've already done it a bunch with seniors. And so you can figure out what grade I will be giving you based on this. If you have an A in the class already, there's not it's a really boring grade adjust. It's 95 and 100 if you've been doing all your homework. So I grade adjust to an A. So I don't grade adjust at all. Yeah. So that's it for how the grades finish up. Now that I've gone through my content I really wanted to get through, are there any added questions? Anything you'd like to see me do before I bid you adieu? I just couldn't help it. It rhymed. If you guys are like, yo, I'm super chillin', this homework was easy, that's cool. You're like, Mr. Kennedy, I would like you to talk about how you made one of those graphs because it just didn't make any sense to me. That's cool. I'm happy to do any of those things. I got my ranting in. Always feels good. This is so sad for Vachin. If we wrap up in the next couple minutes, he's not going to get a chance to show up right before we log off. It's going to be so sad. Hey, Justine. We just ran through some questions. If you have any questions for me on any of the homework recently, please feel free to type whatever you got in chat. Because I am happy to cover anything that would help right now. Anything. Because otherwise, all I do is just sit and plan my video game build for next league. Which is what I do when I'm killing time during the stream here. Clicking a lot of buttons right now. Oh no! Vachin made it! Vachin, I was just talking about you. I was like, so sad if we wrap up right before Vachin shows up. But yes, is there anything anybody would like to see before we wrap up? Any sort of question you'd like me to demo? All you need to do is type it into chat, and I am happy to take a peek at type of question. Justine told you? That's awesome. Showed up just to the memes, Vachin. Well done, well done. Thank you for making me laugh. I appreciate it. Jeez. Alright, so since there are no questions, I'll just do one last little diatribe since, it might as well since we have people here. The last thing I wanted to talk about was, with these parent graph things, what we're going to be doing is moving all of them. So if you don't know our parent graphs, they're like these dudes. Let's see if I can do them all from memory without forgetting any of them. Yeah. That's all 7 of them. Can you post Friday's homework now? Yes, I can post it after this. I won't have a video for it yet, but I can post the assignment. But anyways, I'm gonna kind of talk about how to do it here. All we're gonna do is shift all of these things left and right. So if you shift a line right, you do this. If you shift a squared graph right, you do this. If you shift a cubed graph right, you do this. If you shift a square root graph right, you do this. Notice how the trend is like exactly the same. If you do it inside the parentheses next to the x, it's shifting right. And so it's not actually hard to do all these together because you just do it wherever the x is, on the bottom of the fraction, inside the exponent, inside the absolute value, inside the square root. And if I want to shift up, all I do is like x plus 3, x squared plus 3, x cubed plus 3. You do the adding or subtracting on the outside of the parenthesis away from the x. So we keep the absolute value of x inside, and that's up 3. And so on and so forth. And this can actually get us through most of that assignment, because left or right is just next to. It's the same rules we've been using all year, so it's not even like I'm teaching something new here. And up or down is on the outside. And this rule works incredibly well and super easily to solve like every single question. Notice how the plus 3 is not on the bottom when it's up or down. And this is really it for that lesson. We're also going to be multiplying things, like 2x makes it 2 times as steep. 1/2 x makes it 1/2 as steep. But those are like pretty obvious as far as how they impact things. If it's multiplied by a big number, it's steeper. If it's multiplied by a number less than 1, it's less steep. And that's kind of it. So that's what we're going to be doing next lesson. This is a little intro. I'm probably going to be making this exact table-y dude during the next lesson. So, yeah. Why do we have slow mode? So Vachin, I got invaders because one of my former students makes thumbnails for like a bunch of popular YouTubers like play Fortnite or Minecraft or some crap. Anyways, the trolls from those chats have been invading my calc chats sometimes. So I did slow mode to not allow them to disrupt too much. Because they can't be as obnoxious, and I can figure out which one it is and time them out before they can post multiple things. So, it's actually to deal with trolls, is the reason I'm in slow mode. I'm sorry. Butchin. Anyways, that's it for me. I'm going to post Friday's homework because I have it on my desktop here. So it's actually no problem for me to post. I just need to save it as a PDF and upload it. So that'll be posted in, I don't know, less than 5 minutes. And later, dudes.